with the links to YouTube. Okay. So last time we basically covered the first five chapters. There's one or two questions still that we need to do on binomial and Poisson, and then we will go into the rest of the other chapters. Okay, so let's look at this one. They tell us. Okay, we can't make it. Let's try and make it a bit bigger. So obviously the question follows on to other data sets, but when they say to us, okay, previous studies suggest that 1 in every 4. So let's just put that down, 1 in every 4 schools have shortages of teachers. Suppose 10 rural schools, so we now know that are selected independently of each other to check whether or not each school has shortage. Which of the following statements is incorrect? Okay, so let's look at. I'm just looking through that's definition, so we can do that first. Here we will need to look at the table that we can work out with a formula. So I'll rather do that one also first before I need to go to any table. So remember, binomial, the mean for binomial is n times the pi. Here we will need to work out a probability, and here we will need to work out a probability. So let's look at the first one. In a binomial experiment, each trial is independent of each other. That is true. Also, how we know it's binomial is that here they tell us, suppose 10 rural schools are selected independently to check whether or not each school has shortage of teachers. Okay, so we know that basically there's only 2 events happening. Do they have shortage of teachers or don't they have? Okay, so binomial, each trial is independent. Let's look at option 3 first. So we know n is 10. The pi is 0.25. And that will give me 2.5. Then we're looking for incorrect one. So the incorrect one is C. Okay. To work out the other 3, and again, I don't have my textbook with me, but let me quickly just Google probability table. Okay, so let's hopefully to check if I just want to get one with, what was it, 10, sample 10. Okay, so again, I'll going to put this link in the table as well, like in the chat, so that you have it. So if you need to and you don't have all your, and I'll put the link into the notes as well. Okay, so here you can see we've got N10, and then if we need to look at that 5 out of 10, then we will just go across to 5. Remember we said that the pi was 0.25, so there it would be 0.058, and let's just quickly check 0.058. Okay, so again, you can nearly do that with all of them. I am going to put that link just in the presentation as well. Just that I know some of you, it's if you don't have your textbook and those kind of things with you, then at least you can use the website. And again, we're only left with 1610 now. You guys are allowed to use any of the other tools. So you are allowed to Google a table. You can use other stuff as well. So if you don't have a table in front of you, please use this link to get to it. I also posted the link in the chat. Okay, so you will then basically do the same thing for the other two, that you just look at the table and see if it is correct or not, but it is supposed to, because option C is the incorrect one. Okay, then there was questions on the chat about sometimes looking at the formula. Please never use the formula to work out the probability. It will just take time. You can make mistakes. There is not a set formula on your calculator that does this, so you will need to nearly work out all of those things and make sure that you don't make a mistake in the calculation. So when it comes to working out probabilities, I would rather just go to the tables. If I give you the formula, then it's something else. Then we use the formula, we put in the information that they give us, and then we see if there's anything that corresponds to it. So let's just write that formula out again, and then we can just complete it. Okay, so suppose further that the number of grade 8 absence are Poisson distributed with a mean of 3. So we know lambda is 3. So that's the first thing we can populate. So what I would have done is check, okay, we've got e to the power of -3. Okay, unfortunately, all of them have it, so we can't really take any of them out yet. Use the formula to calculate the probability that 2 learners Okay, so now at least we know that lambda was 3, and with that they tell us x is 2. Okay, so then we can say 3 to the power of 2 e minus 3 over 2 factorial. Okay, and then if we need to simplify that, 3 to the power of 2 is 3 times 3 is 9. 2 factorial is 2 times 1, which gives us 2. So the final answer will be 9 divided by 2 is 4.5. E no, minus 3. So 4.5 e minus 3. Okay, so the other ones would have been maybe if one ignored the x's. Yeah, don't know how one would have gotten to the others. It could have been also if you have said 3 times 2 divided by 2 to get you the 3. Okay, so this one, they gave you the formula. Then you use the formula because you need to basically answer what the answer would be if you basically work out the formula. Okay, so this is the only time that you nearly would use the formula is if they direct you to do it. Okay, let's skip that one because that's also binomial. Let's go into normal distribution. So with this question again, it is a definition type of question. So let's look at, and what we normally would do with a definition is look at that whole chapter nearly and pull a few things out of that chapter to put it into something like this. So let's first see if it's correct or incorrect statements. Okay, so incorrect. The z-score of a mean of a normal probability distribution is 1. Okay, this already doesn't feel right. A z-score of a mean of a normal probability. Remember, this whole thing is a normal probability. Just fix this is a normal probability distribution. The z-score is only at 1.1. The other areas is still different. So there you have -1, there you have 0. So that is definitely not correct. If I set the z-score where the mean is 0 and your standard deviation, then it's something different, because then you can pinpoint it. But here, normal distribution, that whole thing is a normal distribution and is only at 1 point. You've got a z-score of 1. Okay, so that's definitely incorrect. In the exam, incorrect, continue, don't waste time to look at the others. But let's just look why the others are correct. The smaller the value of a standard deviation, the narrower and steeper the curve. Okay, so let me try to So let's say this is the normal distribution with a standard deviation of 2. So if I change that standard deviation to 1, the curve would suddenly become a bit steeper and a bit narrower. Okay, so that's not a very nice picture, but I think you get the message on it. Basically squashes into around the mean. Okay, so the smaller the standard deviation, the closer it would go to that mean and that curve. So that is nearly what that means. So it is correct. The mean of a normal distribution can be any numerical value, negative, 0, positive, true. And again, we can see here that 0, that goes to positive, that goes to negative. So yes, it can be any of those three. The area to the right of the mean of a standard normal distribution is 0.5. To the left is also 0.5. So that is correct. Everything will add up to 1. And then 95.4% of the values of a normal random variable are within 2 standard deviations. This one is correct. So that's why we normally use a 95% confidence interval with the questions in study unit 7, 8, and 9. You guys can just check. It is in study unit 6. So just check for the plus minus 1. I think it is around 64.5%, but please just check. And then the standard deviation of 3 is normally around the 99%. So that's why we normally use those 3 markers as the ones that we normally talk about. But just check for me if those 2 are correct. So that if I ask you for standard deviation of 1 and standard deviation of 3, that you know that as well. They will only ask you 1, 2, and 3, because that's the ones that are normally also in the textbook. They won't go further than that. Okay, so that is definition on study unit 6 to talk about the definition side. So let's quickly go into the next one. So this is one way that they can ask you to use the Z table. Some of them you will see they don't give you a value, like option 1, like option 2. So those 2, it's nearly to use again some of the theory. I will draw it for you to see if anything is there out of the ordinary. The other 3, sorry, we will need to use the Z table. Okay, so let's look at this one. So I'll draw that one first. So, and there goes my screen again. So Z bigger or equal to minus 2.8? Okay, so it's basically that whole area. So let's look at the other one. One minus z bigger or equal to. Okay, so here's 2.8. Z bigger than 2.8 is that. 1 minus that gives us this area. That area and that area is exactly the same. Okay, so you can go and look at the tables. It will give you exactly the same answer. Okay. When we look at option B, so this one is correct. We need to find, unfortunately, the incorrect one. Okay, so if we look at B, the one is Z smaller or equal to 2.1, so it's that area. And is that equal to Z bigger than 2.1? Yes, it is. So again, if you look at your Z tables, at the value of minus 2.1, the value of a bigger than 2.1, exactly the same. These two is, and if you look at the definition statements, this is because of symmetry. So because around that mean, and that's why we also saw 0.5 on the one side of a mean, 0.5 on the other side. So because of symmetry, the minus 2.1 area and the plus 2.1 area is exactly the same. Okay, so that's purely out of the definition, out of the symmetry around the mean, but you can also go and look at your Z tables, and you will get the same values. Okay, so let's look at the next one. Z between certain things. Okay, so Z is 0, so smaller than 0, but bigger than minus 2.8. Okay, so you're looking for that area. So here the easiest probably is, remember at 0, this whole area is 0.5. So what I will do is I will go to my Z table, the minus Z table. So where Z is equal to minus 2.8, I get that the probability is 0.0026. Then to work out this orange space, one needs to say, well, we know that whole area is 0.5. So 0.5 minus the 0.0026 give me my answer. And then if I look at that, it will be 0.4974. Okay, and not really a problem with what we're doing, but the problem with a question like this is it's taking time. So that's why nearly, if you look at all these options. It does take time when you get a question like this. So again, if option A was the wrong one, please submit it as your answer and continue, and not go through all of them, because really this can take you up to 5, 6, 7 minutes to nearly work out all of them, which is extremely long. Okay, so let's look at the fourth one. So here they want us between minus 2.8, so at least we add that from the top, but till 2.1. Okay, so we need to get that area, and then we need to get this area, and we need to add two of them together. Okay, so to get to the red area, again, sure, there's a few ways to do that. One can use the negative 2.1 in the same instance as this and get to it, or one can go to your positive table. You look at what 2.1 is, and 2.1 will then give you 0.9821. But remember, that is that whole area. So now again, we can do two things. We can use that whole area and only subtract that small area, which was the 0.0026. Or we can say, I only want to get to this space, so it is 0.9821 minus 0.5. And I did the minus 0.5 because that would be that whole area. Okay, so one can do it two ways, and you need to decide which one is the easiest for you. So if I do that, 0.9821 minus 0.0026, I do get 0.9795. If I do this, 9821 minus 0.5, I get 0.4821. But remember, this is now only that red area, so I need to still add the orange component. Which also then gives you 0.9795. So yes, you can definitely use both. It's up to you which one is easiest. There might even be an online calculator as well that does that for you. And then the last one is basically asking, what is that area between 0 and 2.1? And we actually have worked it out as the 0.4821. 4821, there's 4221. So that is the wrong one because it should be 0.4821. Okay, so this one is nearly worst case. because it really takes a lot of time. So hopefully something like this will not be in the exam, but more something that you actually just need to really work out one Z and get to the answer. Yeah, because the previous one, as you have seen, it just takes time. Okay, so let's go into chapter 7, where we now talk about random normal random variables. They give us information around it. So what we would need to work out is a Z, and then from the Z, we will need to go to the table and find a probability. So in chapters 7 and 6, we normally don't include a sample size yet. They're not talking about the sample, so we ignore it if they don't tell us. So consider normal random, calculate the probability that the random sample is at most. Okay, so let's again, please use this table, because also if sometimes I also need to understand what at most is at most. Okay, so we can nearly change this, and let's do it from the start. So we can now see that what we will need to work out is Z smaller or equal to that. So when we get to the answer, it will be Z smaller or equal to. I don't know yet if it's a positive Z or negative Z, but we'll draw it in when we get there. Okay. So X, let's consider a random variable with a mean of 3000. So that is your mean of 3000. They tell us at most 3800. And they tell us the standard deviation is 1800. And so that is going to be our Z. Let's see, Z will be smaller or equal to 3800 minus 3000 divided by 1800. So I get a Z of 0.4444. Okay, on the tables, we round it off. So it will be 0.44. Okay, so we're looking at a 0.44. So somewhere there, we will need to work out what is that probability. Okay, so let's get a few clues. So we know from the previous questions, where it's 0, that area, and let's draw it in orange, is already 0.5. So whatever we are going to get is going to be more than 0.5. Yeah, so we can already eliminate that. Smaller than 0.5, we can already eliminate that, eliminate this. Okay, so we are sitting with two possible options of what this will be. Okay, so then if you go to the table, look at Z of 0.44. What is the answer that you get? So let me again quickly Google Z table. And I have one, so let's hope the one that I click on is, okay, so we said 0.44. 0.44, 0.4, 0.44. Okay, so 0.67. I'm also going to put this into the chat if anybody wants to access it, but also add it to. So again, if you don't have a table close by, here's one that you can access. So the correct answer for us was 0.67. Okay. So this one hopefully is more of a question type that you will get, that you need to work out the Z, go to the table and get it. Much quicker than looking at 4 or 5 different ones to answer. Okay, next one. Again, we're looking at probabilities. Now we're looking at, and I think this is the important one in this instance. Do we know what is it sample or population standard deviations? So let's look at what they give us. Upon conducting further research, education department found that normally distributed with a mean of 114. Okay, so at least let's put that in, mean 114, standard deviation of 72. Okay, so we're still busy with just working out the Z. So in this instance, still we do x minus mean divided by standard deviation. So it is x is 100. Okay, so in this instance, we're going to get a negative Z value. So just again, if we go to the table where that is 0, so this value is going to sit somewhere on the negative side. What is the probability that the learner who is less than? So I should have again, okay, so less than. So less than is to this side. Okay, so let's quickly check. 100 minus 114. 100 minus 114 divided by 72. Okay, I get minus 0.1944. So if one rounds that off, will be minus 0.19. Okay, so that is minus 0.19. Okay, so again, we see the bigger area there is 0.5, so this will be less than 0.5. Option B is not the option. Option C is not the option. Option E is not the option. Okay, because it must be smaller than 0.5. So 0.19, let's see if we can get it 0 or minus 0.19, sorry. Minus 0.19, 0.4247, 0.4247, option D. Okay, so again, we're looking at using the Z formula. From the Z formula, we go to the Z table, and then we identify or get the answer from there. I like to draw this picture every time before one nearly looks at it. It just makes, for me, I like to see something visual. So it just makes visually um, just some much simpler for me to see it and to see what the answers could be nearly. And that is more to eliminate some of the answers that we get. Okay, so let's go into the next one. Now what they're doing, and they love to ask this question. So we're looking again at set values, but in this instance, they nearly want us to determine how many people are in this graph nearly. So they will give us certain information so that we can pinpoint some values, and then we need to get the total number of students. So let's first look at the info that they give us. Emotionally challenged. Okay, so EQ score of high school learners is normally distributed, okay, with a mean of 80, standard deviation of 20. If there were 2969 learners with scores higher than 95, how many students took the EQ test? Okay, so let's first work this out. So Z, and they tell us higher. So let's first work out what that Z value is. So 95 minus 80, and then that's 15 divided by 20. So that is 0.75. Okay, so that is Z. So that Z value is 0.75. We know now in that space, there is N equal to 2969. Okay, but we first now need to find out what is this probability. Okay, so we need to find out what is this probability. So 0.75. So let's go to that table again. So we know that Z is 0.75, 0.75, so 0.7734. Okay, so this area is 0.7734. So the area we're looking for is 1 minus 0.7734. Okay, so the probability is at 0.2266, because that is 1 minus the 0.7734. Okay, so now we need to use a bit of math. So if 0.2266 is the probability, and that is equal to 2969, how big is 1? Okay, so we will need to divide the 2969 by 0.2266 to get the probability of 1. Okay, so the probability of that whole area. So the 2969 divided by 0.2266 gives us 13102, okay, which is option C. Okay, so this is really it's not the easy one. And I've seen in the last few papers, and I think you guys would have seen it in the October, November one as well. They love to ask something like this, where you nearly need to work backwards to get the answer. So what they also nearly sometimes love to ask is they will give you a probability and you will need to work out the Z. So that is also something that sometimes comes up. Okay, so let's go to the next one. So again, let's just mark this. If you have time again to go over this, just make sure that you can get, because this might be again coming up in the exams. Okay, next one. So they give us information, then they ask us to determine the standard error. Okay, so standard error, the formula for the standard error is basically what is below the line when we look at calculating the Z. So that's the standard error. So let's look at what they tell us. A random sample of size 120. Is drawn from a normal distribution population with a mean of 160. We don't need that mean. We only want to get the standard deviation. So they didn't need to give you the mean. So the mean was extra information to confuse you. So 50 divided by the square root of 120 will give you 4,5644. So again, round it off to 2 decimals, and we get the option B. Okay, so what we also normally can ask, I don't know if I've got something like that in here, is also the standard error with the population, or the population proportion, sorry. So just remember to look at that formula as well, if they do ask one of the standard error questions. Okay, next one. Let's go into confidence intervals. The first one will probably a Z. The second one will probably be proportion, and that's how they always like to ask it in the exams as well. And normally you will get one of each. So let's look at the Department of Basic Education findings from a survey of 150 learners. Okay, so let's jot down the variables that we have. Suggest an average time of 114 from home to school at one of assume the population standard deviation. So population standard, we can work with a Z. Of learners time is 72. Because it's population standard deviation, it's set for 95%. We can already say that Z is equal to 1,96. You don't need to prove it. You don't need to show it. When it's 95% for Z, it is always 1,96. And now we will basically need to work out your confidence interval. So the formula is your mean plus minus Z, and your Z you normally will times with your standard error. Okay, so we've got the Z 114. We've got, sorry, the X as 114. We've got the Z as 1,96. We've got the standard deviation as 72. And your sample as 115. Okay, let's work that out. Normally, what I will do is, because 114 is going to be in the middle, I normally just check that all of these numbers must be bigger than 114. All of these numbers, so on the upper limit, everything must be bigger than 114, which it is. On the lower limit, everything must be below 114, which it is. So with my method, I would not have been able to there cancel out any options. So we unfortunately need to go and work it out. So 72 divided by the square root of 150 times 1.96 is equal to 11.5224. So we will round it off to, again, 11.52 because we're only working with two numbers. So the top one is 114 plus that is 150, 25.52. Okay, so already there is my one option. There isn't anyone else, so we can pick it with even looking at the other option. But again, if you say 114 minus 11.52, you will get 102.48. Okay, which is option B. If it was sample standard deviation, we would have used T, and then we would have needed to go to the T table to look at the T value. With this bigger sample, it would probably very close to 1,96, but it will be just a bit different. But they tell us it is population, so we straight go for the Z. Okay, so after the mean, they will ask you the proportion one. The proportion one we'll do exactly the same nearly. We'll look at to get the N value. We will need to get your P for your proportion, and then also just remember the formula. So it's Z times, and again, the standard error of proportion. Okay. They might even in a question just tell you you're working with a confidence interval. The standard error is something, work it out. So just be always, this part is your standard error. The same in this question. This was your standard error. So just if I talk about standard error, that is the part that we're talking about. Okay, so let's see what information do they give us. Consider most of the school reported decline number of absentees. In a sample of 150 from that municipality, 114 schools reported a decline. Construct a 90% confidence interval. 90% confidence interval. If you go to your Z, it is 1,645. So again, there is a Z table or the table that is in your study guide that tells us 90, 95, and 99%. And you can just use that information for that. Okay, so let's just get what 114 divided by 150 is. So that is 0,76. Okay, so 0,76 is my P. So once again, I will check upper limit must all be bigger than that. Lower limit must all be smaller than that. Okay, unfortunately can't eliminate anything, so we need to work it out. So 0.76 times 0.24 divided by 150. Take the square root of that, and then if we multiply by 1,645, we get, okay, so that, I'm just going to say multiply by we get the answer is 0,05736. We round it off to 123, so we can take those two away again. So 0,76 plus that. So on the top end, we're looking at 0,817. Okay, it's there. And then at the bottom end, if I subtract it, we're looking at 0,703. Okay, which is that one. So option A. What I've also seen, what is quite interesting, is that they don't, in this one, it might be that there's two options, that is 0.817. So that you need to work out the other point as well. But if there's only one, again, I would save time to say, okay, well, I've worked it out. There's only one. It must be A because it can't be one of the others. Okay, and here you can see they made very much duplication errors as well. Okay, so that is looking at confidence intervals for your population proportion. We did the one also for your around the mean. Okay, so then after confidence intervals, we basically go into the chi-square testing. what I've also added here for the chi-square is this was from the study guide, and this is nearly what they can ask you in the question. So they can ask you something about the hypothesis. They can ask you something around the degrees of freedom. They can ask you to work out the expected value. They can ask you, let's make this just a bit, but it's still big enough for you to, they can ask you to work out the test statistic. So there's a few things, but this is nearly what they can ask you. So let's see in the options. Okay, so which one of those statements again incorrect? The test statistic has R minus 1, C minus 1 degrees of freedom. Okay, so that's correct. Where R is the number of rows and C is the number of columns. Okay, that is correct. Okay, so we have number of rows, number of columns. So that is one of the correct ones. We are unfortunately looking for incorrect. The observed frequency for each cell is equal to row total times column total divided by n, where n is sample size. Okay, that is how we actually work out expected and not observed. Observed is actually just the number that you have observed. So this is the incorrect one because it's the expected value that we work out with this one. Two variables are qualitative, correct. The null hypothesis is that the two variables are independent, correct. Null hypothesis always wants to test independence, where the other one does not. Remember, what they can also use for not independent is dependent. So just, they might sometimes use the word dependent as well. If the observed and the expected frequency for each cell are equal, then the test statistic will be equal to 0, which is correct. And let's just check if that and that is exactly the same. That at the top will be equal to 0. So the sum of 0 is 0. And then your t-stat will be 0. Okay, so that is definitely correct. Okay, so first time in a while that I've seen that they nearly ask something around a definition type of question with chi-square. Normally they ask you other stuff, like maybe to work out the degrees of freedom or work out one of the observed frequencies or something like that. But let's see in this one what they ask. The following 2x3 continuousy table contains observed frequencies and expected frequencies from a sample of 364 observations. Calculate the chi-square test statistic required to test for independence. Okay, so let me just put this back. So they want us to go away. they want us to nearly do that. That is what they want us to do. They give us the observed, they give us the expected. So we will need to do, I'm going to use Excel. You guys are allowed to use Excel. So, and on the table or Excel, that spreadsheet that I have shared previously, one can do it. I am going to, just for this question, quickly going to create one, and I will share that in any case also now after the session with you so that you have it at hand. Okay, so all that I did, I just want to show you 55, 40, 79, 34, 5600. So let's make it just bigger. Let's quickly put in what the expected values would have been. So it would have been that total times that total divided by that. I will fill in the totals now. And I could have anchored it, but I'm too lazy now to anchor the cells. Okay, so that is our expected frequency. So let's just quickly check. 42, 45, 85, 46. Okay, so at least we know that has been calculated correctly. And then basically the formula says to work it out, observed minus the expected divided by, so let's just put in another one for you. I'm going to put in that. So it was observed minus expected to the power of 2. And that was divided by expected. And let's just make sure again. Observed minus expected to the power of 2 divided by expected. Okay, so we have that. So let's just check. It was the same for that one. Used that one, that one, that one, and that one. So if we then add all of that together, we will get our value of 9.4. Okay, so I will definitely share this with you so that when you guys change those as your input numbers, it will automatically change everything else. Yes, I will put this onto the chat, but 9.4, there is 9.4. So just when you guys get it, maybe something like this in the exam, and that number is 50, you will see automatically all of the other things have changed. Okay, so you will be able to just use this for that. Okay, let me just save it so that I can send it to you before I forget. Okay, cool. Okay. If you want to do it manually, it is going to take time because then you need to, they have given you the numbers, but when you're going to do this calculation, like I did in Excel, which is fine to do it, but you're going to do it for 1, 2, 3, 4, 5, 6 of them, and then you will need to add all of them. So again, just the chances of an error coming in is very high if you need to do this on a manual process. Okay, let's look at the next one. Again, we're looking now at the regression chapter definition first, and then we'll go into one of the practice ones. Which one of the following statements is incorrect about concepts of simple linear regression? A correlation coefficient of 0.1 indicates a weak positive linear relationship. Weak, yes, because it's smaller than 0.5. Positive, yes, because it is 0.1 and not negative. So that is correct. Strong would have been anything like 0.6, 0.7. Negative would have been minus 0.1 or 0.2 or whatever. Okay. The least square method estimates the regression equation by minimizing the error sum of squares, which is correct. This, you basically can look under least square methods. That is purely straight out of the discussion guide. You can even Google what least square method, and that is purely just copied out of the study guide as a definition. The correlation coefficient always takes on values between 0 and 1. Correlation coefficient is R. For R, it is always between -1 and 1. If it was the coefficient of determination, that lies between 0 to 1. So coefficient of determination is between 0 and 1. Correlation coefficient is between -1 and 1. Okay, so the incorrect one is option C. The coefficient of determination can be interpreted as the percentage of the total sum of squares that can be explained using the estimated regression equation. Correct. Again, purely taken out of a study guide or book. That is basically spot on the definition. Just remember the coefficient of determination is for R square. So if you want to look that up, the slope and the intercept of the estimated regression equation are estimated using the least squares, also correct. Okay, so in this instance, we talked a lot about the least square method. You don't need to understand what the least square method is, but please just look at some of these very technical kind of definitions. And even if you mark a space in your study guide specifically for regression, or even look at definitions of regression or some of the it might assist you. Even have this slide at hand when at the end of your exam nearly the regression questions come up. It might even be that some of these concepts they ask again. Okay, the last one, we go into nearly a practice of the regression. So let's make this bigger, at least that we can see, and we can just change this up a bit. Okay, so in here, they give us the data set, they give us certain answers to that data set, but we will need to decide, is these ones correct? So here they say, is only free right, only one, only that, only that, only that. So again, what I would do, and here you have two options. Most of your calculators, you can put in the X and the Y values to get your data set in, and then you can get to these answers. I'm going to again quickly use Excel. So let me just first put the X and the Y's into a table, and then we can try to work it out. Again, I will share this with you. It's just 10, 59, 10, 11, 11, 13, 12, 12, 10. I'll share now on the screen so that we can just double check the answers. Okay, so let's just 10, 178, 15, 274, 9, 155, 10, 207, 11, 208, 11, 184, 13, 224, 12, 19, 12, 196, 12, 246, 10, 168. Okay, so let's get first the mean of them. So mean is just average. Okay. Average of X. Oh, sure. And look at what which one of the calculated is incorrect. Okay, so that looks very weird. Okay, let's just check X, Y. x 11.3204. Okay, so that is wrong. Which one of the following calculated quantities one is incorrect? Okay, that one is incorrect, which is weird. Okay, let's just, okay, feels weird. I think there's definitely a mistake here, but let's calculate the next one. I think there should have been a comma there, because if you look at the next x and things, it is right. But in the exam, again, if something like this happens, you can WhatsApp me and say, John, just ask about this question. It feels like there was an error. Okay, so here we need to work out the x, I minus the mean to the power of 2. So let's say x minus the mean to the power of 2 x minus the mean to the power of 2, and we need to sum that. Okay, so that's option 28.1, option 2, 28.1, correct. So I think that was probably a typing error. Okay, let's look at, so we need to work out the sum of xi minus that and the other one, the y's. So let's, again, we basically, let's copy that over, but we do it for y. Okay, but when they ask us, and let's just get it right. So the x1 minus or times the y, and then the sum. So the x times the y, and we basically need to take the sum of that. Again, that is, again, not right. Okay, look, there is no 2's. So I assumed it's the 2, so let's take the squares away. How easy it is to make a simple mistake like that. So can't just do that. So let's copy that over. I just assumed, and obviously I assumed wrong. So it is not to the power of 2. So again, I'm setting this up so that you guys can use it if you need to put in your own numbers. Okay, there we have 511, which is for 511. Okay, and now we need to remember if you work with B0, B1, which one is for slope, which one is for intercept. So let's just have a formula slope. So there is a nice formula for that in Excel. So first you need to put in the y's. Then you need to put in the x's. And then your intercept. Also a nice one again in Excel. Also be just careful. First you need to put in the y's and second the x's. Please don't do it x first, y second, then you will make a mistake. So slope 18.18, intercept 1.49, 18.18 is correct. The intercept is the wrong one. Okay, so in this instance, actually 1 and 4 was wrong, but I again think that should have been 11.3 instead of 113. Okay, but again, please, if something like this happens in the exam, please let me know, and I can just let the lecturer know as well that there is some error or some mistake maybe in the question. Okay, that is it, everyone. I'm going to share the presentation. I am going to share the recording, and good luck for Monday.